like from the point of starting the data collection to actually, or not data collection, even just data curation. It could be from, from the synthetic data, from the data collected from your sensors, all the way to seeing your performance improvements, right? Or whatever your target model improvements are. It's a very long process, right? And Chenji, you and I we have done this sort of work together in our previous experiences where when I used to report on the performance analysis of the data, I would be like, oh, this is only a 2% change of this particular failure mode, while you were expecting a 15-20% change, and that didn't match. Or it could be the other way around. The other way around is more surprisingly, pleasing than the first one. But what anchor points do you keep in your planning, or maybe even execution process, from your initial data problem to performance problem? What is your guidance for the teams to manage that end-to-end pipeline?
Sergey, can you clarify your question? What do you mean by the anchor point?
Like, what would be the things which you will recommend folks in the same space to watch for, right? Like, you don't want to spend too much time in doing collecting a data or training a model one way and then not getting a result at the end. What would be some of the guardrails that you recommend to keep on the way, so we don't kind of are on the path of high probability of success at the end?
Yeah, there are definitely different ways to do that. I think we just talked about using synthetic data. That's the way to speed up this kind of a data collection and improvement loop. There's also, Motional had also publicized our continuous learning framework, which is another way you can speed up this iteration. So you can mine those highly impactful error cases directly from your previous training dataset and upsample them, or add them into your training distribution. That can greatly speed up your higher training. We can also use semi-supervised learning, which is also something I experienced in the past. That gives you really good kind of cost to kind of impact kind of a ratio, right? Because as we all know, human annotation most of the time is quite expensive. But semi-supervised learning, which means that you bootstrap by a very strong, powerful kind of auto labeler, so you can get a big batch of cheap data to work on. Depending on how much you can afford, you can also try that and make sure it does not skew the distribution too much. But from my personal experience, I think maybe 1-10 kind of a ratio between human and semi auto label is the right balance you can strike. Yeah, that's high level advice I have. Yeah, how to make this quicker iteration. Yeah.
Right. Kuchan, anything you want to add to that? Like, just performance.
Definitely. Even I do unsupervised learning or some topics of the synthetic data generation. I also maybe a little bit traditional when it comes to like the testing and validation. I believe there is no shortcuts on that in usually. And the way that I'm thinking, it's, as you know, like the testing and validation, probably it's a smaller data set compared to the training. These methods on the testing and validation does not rapidly improve as opposed to like the ML models. You see like the different models every day, the different change of the data generation. This is kind of cumulative approach that you're building, your testing and validation, and that stays there almost forever. So like even the new models are using very old techniques or maybe like the similar benchmarks. This is very cumulative in the industry and also like in academia everywhere. And to the changes point as well, I really think that adding synthetic data and also like the simulations accelerate this. But I feel like this acceleration, it's not. That's not as significant compared to what we are seeing, the improvements in the ML models. So I also see this testing and validation as a kind of building infrastructure, right? In order to train a model, you need to have a good infrastructure, and big companies have built their infrastructure over time. Testing validation is kind of like that for me. It goes from the first principles, but yeah, definitely for the synthetic data generation and also simulations helps this a lot.
I think I have another quick point.
Yeah, go ahead, JJ.
Gushang made a really great high-level summary about like why do we need synthetic data. I can give some low-level tactic ones, but I've been in the tracking space for a while. So one challenging problem in tracking is occlusion handling, right? So how do you track, let's say, actors or agents on the road when they go dark? It will be impossible to actually get human annotation on those because it's counterfactual. You can see them most of the time. Human annotation relies on sensor input. There's one way to do that is you use synthetic data that gives you sort of like free labeling, especially for those counterfactual cases. And now you can even train your system to start anticipate or hallucinate agent actor before they even appear at those critical kind of locations, which may affect your A/B performance.
Right.
So that's another tactical way of using synthetic data to solve specific edge case problems.
Yeah, I remember a very specific, sort of, not going to use the abbreviation. That's an IP from our previous companies, but we had a situation where there was a VRU child running in front of a bus. After the bus stopped, and they got down, they crossed in front of the bus, right? So for the traffic coming to the left of the bus, it was basically a completely occluded VRU, right? And they had to brake hard, to make sure they don't hit it. So I think all of these corner cases, edge cases, they're perfect candidates for synthetic data. Even at DDD, we are trying our best to increase the amount of effort and investment we're doing with building synthetic data sets, because at the end of the day, you want to diversify the amount of data you can provide with the human output, but at the same time, we also want to make sure we have a lot of synthetic data sets ready for key players in the market to commercialize and to use that in your development for accelerating the go-to-market timelines.